Say we have two planes in three-dimensional space. Then we must have one of the following situations. Either the planes are parallel, so they don't intersect, or they're perpendicular, so they intersect at right angles, or they're neither of the above, so they intersect but not at a right angle, in which case they actually form two different angles of intersection, an obtuse one and an acute one. In this video we'll look at how to compute the angle between two planes. So, say we have two planes in three-dimensional space with normal vectors n and m. We saw in a previous video that there must exist a vector a such that the equation p.n equals a.n defines the first plane, where p is a general position vector. Similarly, there must exist a vector b such that q.m equals b.m is the equation of the second plane. Now, the angle between the two planes, assuming they do intersect, is actually equal to the angle between the two normal vectors to the planes. So if we can compute the angle between the normals, then we have found the angle between the planes. Well, we know the angle between n and m, let's call it theta, is given by the equation n.m equals the magnitude of n times the magnitude of m times cos theta. This just comes from the definition of the dot product. So theta equals inverse cosine of n.m over the magnitude of n times the magnitude of m. It's worth noting at this point that if the planes aren't at right angles, there will be two angles between them, an acute one and an obtuse one. Which one this formula gives us depends on our choice of n and m. But we know the two add up to 180 degrees, so once we've found one of them using the formula, we can find the other by subtracting the first from 180. Let's try an example. Let's find the angle between the planes 2x minus 3y minus 6z equals 5 and 6x plus 2y minus 9z equals 4. The normals to these two planes can be found by simply pulling out the coefficients of x, y, and z. So, the normal to the first plane, n, is 2 minus 3 minus 6. And the normal to the second plane, m, is 6, 2, minus 9. Now we need to calculate the product of these two vectors and their magnitudes. The dot product, n.m, is equal to 12 minus 6 plus 54, which equals 60. The magnitude of n is the square root of 2 squared plus minus 3 squared plus minus 6 squared, which is the root of 4 plus 9 plus 36, which is root 49, which is 7. Similarly, the magnitude of m is the root of 6 squared plus 2 squared plus minus 9 squared, which is the root of 36 plus 4 plus 81, which is root 121, which is 11. Finally, we can plug these three values into the formula to get that cos theta equals 60 over 7 times 11, which gives us that theta equals inverse cos of 60 over 77, which is roughly equal to 38.8 degrees.